Hello everyone, this is Unit 1, Lesson 9, Learning Target. I can find the missing side lengths and angles of similar figures by using this angle and proportional side criterion. The do now, evaluate the equations below. You should be able to do these. Go ahead and try them now. Remember the second equation though, you're going to have to distribute a fraction with a negative. So just be careful. This is a tough second equation. Go ahead, start and try the first equation and the second equation, and then we'll come back after you press pause to review your answers. You could press pause now. So we have a distributive property here. It's 3x, and then 3 times negative 4 is negative 12. You have 3x minus 12 equals 3x plus 7. You should be able to tell what type of solution this is right now from this. But if you're not able to tell, you go ahead and you do exactly what you normally do on each side, which is subtract 3x on both sides. Once you subtract 3x on both sides, that means you could go ahead and cancel out each side and get negative 12 does not equal 7. And whenever a negative 12 does not equal 7, whenever there's no x and both sides do not equal, that is no solution. And you should have that down. No solution. Right here I was saying the same x value with different numbers, different other numbers. As soon as that happens, you know that the x's will definitely cancel, and then there will be no solution. Just remember, infinitely many, same exact on both sides, same exact expression on both sides. Let's go over to number 2 here in the do now, and this is a very tricky question, and I'm going to bring up the calculator right now. So as I did say on my other videos, to put your calculator is completely necessary to do this problem, right? And you shouldn't try anything without the calculator, or at least try it and then check it with the calculator. I've said a lot of times during the videos, alpha x is that fraction button, right? And it gets the fraction to come up. So this is a negative 2/3. You notice I put the negative on the top in the numerator. It doesn't matter where you put it. As long as one is positive, one's negative, it'll be fine. And I just, like when I was putting the 2/3 in and I made the numerator a negative, do you notice that if I press enter, that the calculator will just put the negative in front of the whole fraction, because negative divided by a positive is negative. So the whole fraction is negative. So the calculator is thinking, all right, this is a negative number. And then I inputted this right here, and let me just show you how I press negative first now, and then alpha x to bring up the fraction, and then you can put 2/3. Either way, it does not matter. I just wanted to show you the different ways of putting that in. So it's negative 2/3 times 5 is that second part, and it's negative 10/3. Negative 10/3. So I'm just going to go along and combine like terms. I have 6, which is right here, and I'm boxing that out, minus 10/3. And I put that directly into my calculator, and I get 8/3. So I'm going to put negative 2/3 x plus, because 8/3 equals 4x. Now you notice that the x's are on both sides, and you should go ahead and add 2/3 x to get the x's together on both sides. This cancels, and you get 8/3 equals 4 2/3. So let's see what the calculator gives me. 4 plus, and I'm going to put alpha x, 2/3. Let's see what the calculator pops out. 14/3. So that is important. 14/3x. So there's a lot of different ways that you could go about and do this, and I'm going to just hopefully show you the whole thing. All right, you could multiply by the reciprocal, or you could just divide. It does not matter which way. I'm going to multiply by the reciprocal, but remember, if you divide, it's the same thing, multiplying by the reciprocal. When you multiply by the reciprocal of a fraction, numerator and numerator, numerator and denominator, and numerator up here of the second fraction and the denominator cancel out, and you have x. So now I'm going to press alpha x, 3/14, times alpha x again, and it's 8/3. And that is your final answer, 4/7. All right, I'm just going to put a line right here, and I'm going to put 8/3. This is the second method. I'm going to put this in green. So if you have 8/3 equals 14/3x, you could divide by 14/3 and divide by 14/3. So when you put that in your calculator, you get alpha x, 8/3 divided by alpha x, 14/3. Just like that. And you will get the same answer. So this is your second method. Right? It's up to you which one you want to use. A lot of people like to divide, just like this, like I just did on the second method, but I'm just telling you this is the reciprocal, and then this way is the you just dividing by the number that is next to x, which happens to be a fraction. And hopefully you did get that. That is a tricky question. All right, let's go on to page 2. So here's the launch, and launch is pretty easy right now. This is called a proportion. Anytime that you have two fractions with an equal sign in the middle, you have a proportion. And if you remember that how you solve proportions, and I'm sure you do, what do you do with it? How to solve a proportion? What do you do to solve it? Yes, you cross multiply. All right, so I'm going to just draw some circles around, and I'm going to use different colors to show you. All right, let's go ahead and multiply. 12 times x is 12x, so I'm going to write that down, 12x. And 36 times 3, just remember, use that calculator. 36 times 3, enter 108. Then this is a single step equation. You have divided by 12, divided by 12. And again, we're going to use our calculator. 108 divided by 12. And is 9. All right, so easy. Remember, a proportion is this first fraction, 12/3, is going to be equal to, or is equal to, 9/36. And you had to find that x. Those are two fractions that are in proportion. So take a look at number 2. It says the following triangles are similar. Similar. And we'll go over what that word means. But right now, we're talking same shape, different size. So similar figures have the same shape and different size. And they also have all of their corresponding angles equal, right? They're congruent. All of the corresponding angles are equal in similar figures. So if you think about this being a right triangle here, you would draw a box there. This is 90 degrees. This is a corresponding angle. Even though it's smaller, it's still 90. If this was, let's say, all interior angles of a triangle equal 180 degrees. So if this was, say, 30, this would have to be 30. They're similar figures. So that means corresponding angles in the same location are equal to each other. So, and if this is 90 plus 30 is 120, you minus that from 180 and you would get, I'm just making up the numbers, and you would get 60. If this is 60, this would have to be 60. Remember, similar figures have corresponding angles that are equal. Now the sides aren't equal because remember the sides of similar figures are different sizes. So that means that they're different measures. So you have 15 and you have 10. You have x and 8. So the rule is in similar figures, corresponding sides have to form equal proportions, equal ratios. So we have to figure out and match up the corresponding sides in a proportion and then solve for x. So what I like to do is just really take the first two sides that I see in this triangle. So I see 15 and x. That's what I see. And that's what I'm going to make as a fraction. I'm just going to write that down as a fraction. A lot of people jump from 15 to 10. I don't do that. I just put 15 over x, and that's the first fraction. So since I used 15 first, I'm going to match up the corresponding side and say, all right, no, that's the wrong color, but you get it. It's yellow. It's supposed to be yellow because that matches up the corresponding side. Just like that. So I'm going to match this corresponding side up with the 15, and I'm also going to match that x up with the 8. So since I made 15 over x as my first fraction, I have to have 10 over 8 matching up the corresponding side. This side over this side, that means this side over that side. Now cross multiply, and we're going to figure out how much that x is. We're going to cross multiply first and this second. And it doesn't matter which one you do first. So 10 over x, 10 times x is 10x. 15 times 8, just to make sure. 15 times 8 in the calculator, 120. Then you divide by 10 on both sides. X equals 12. So I'm going to put 12 in here. 15 and 10. 15 over 12 equals 10 over 8. And we found that missing side. Similar figures. Corresponding sides form equal ratios. Corresponding angles are equal to each other. Alright, so here is a fast finisher. Fast finisher is right here, 17.5 and 11 for the first triangle, and 8.75 in x. This fast finisher should say that these are similar figures. So go ahead and see if you could do this one. All right, just remember, you're talking about matching up the corresponding sides. All right, so the corresponding sides, I'm going to match green with green and yellow with yellow. And that doesn't come up. Yellow, black, black. There you go. Black with black, yellow with yellow, green with green. So here we go. I'm going to do the same exact thing. I'm going to create a proportion, right? And in my proportion, I'm going to use 17.5 over 11. That's the first thing I'm going to put down, 17.5 over 11. I didn't even look at the other triangle yet. So if I matched 17.5 over 11, I'm going to have to use the corresponding side to 17.5, which is 8.75, and the corresponding side to 11, which is x. Now go ahead and cross multiply, and I'm going to draw my loops. Hopefully you're ahead of me on this right now. And we have 17.5x equals, and let's go ahead and do 11 times 8.75. That is 96.25. Divide by 17.5. Divide by 17.5. This cancels x. Let's see what x comes out to be. I'm going to press divide. It's going to take this 96.25 and put it right there automatically. And I'm going to divide it by 17.5 and enter 5.5. All right, and x is 5.5. That is that. So for the next page, it says exploring new groups, some facts that you can tell about the other triangles if they are similar to one another. All right. So let's just take a look at angle A. You see this little like part of a circle here? That says this is the measurement of A, whatever it is. See this? That it says one part of the circle there? That means A and X are congruent to each other. Angle A and angle X are congruent. B has two parts of a circle. Y has two parts of a circle. So that means that B and Y are congruent. While Z has three parts of a circle and C has three parts. So that means that C is congruent to Z. And it says that triangle ABC is similar to triangle XYZ. And please put an arrow to this to that right there, that squiggly line, and that means that it is similar. And by the way, we mentioned this, the equal sign with a squiggly line, I shouldn't put equals, all right, that means congruent. And just a squiggly means similar. All right, those two things you do need to know, because a lot of times on a Regents or a test, they're not going to use the word similar. They're going to use this, and you have to know what that means. All right, so triangle ABC and triangle XYZ are similar. All right, fast finisher. Solve for angle C. So this is what we have to solve for. I always like circling what we have to solve for. Based on the facts you've listed about similar triangles, without solving, can you find the measure of angle E? So these are similar to each other. So we're telling you that. So I'm going to start circling the angles here. And here's angle A, and it's measure of angle 20. It's a measure of 20 degrees. Angle F is the same. These are congruent. All right, they're corresponding angles and they're congruent. Angle B is 115 degrees, and angle D is 115 degrees. Those are corresponding angles. C and E would have to be equal to each other. All right, they're going to be equal to each other because these are similar figures, and all corresponding angles of similar figures are congruent. And then if you have those two measures, the interior angles of a triangle equal 180 degrees. You have two of them that they give you. It's very easy to find the third. So how would you find that third? Taking a look, I'm trying to pause here so you could actually do the problem on your page before I put it on this page. All right, so just remember, all interior angles of a triangle equal 180 degrees. So what we're going to do is we're going to add 115 and 20. And right now, I know that that is going to be 135 degrees. That does not mean that angle E or C is 135 degrees. You could tell this is an acute angle. This is an acute angle. So what do you think you need to do to figure out what the missing angle is when the other two interior angles are 115 and 20? Well, you added them together, and then you're going to take 180 because all interior angles of a triangle equal 180 degrees. So we're going to take 180 and minus it from 135 and minus it from 180, and you will get 45 degrees. So the measure of angle E is 45 degrees. That's what the question wanted you to find, but so is the measure of angle C. These are corresponding angles, so that means they are congruent to each other. So the measure of angle E is 45 degrees. All right, just remember, similar figures, corresponding angles are equal to each other. It doesn't matter big, small, doesn't matter. But the corresponding sides form equal ratios. And let's go on to the next page and see what we have. So these are just facts, and I'm just going to read this to you, so we're just going to go through this quickly. Remember, two figures are similar if they have the same shape but not necessarily the same size. So a figure could be similar and congruent at the same time because if it is exactly the same size, we could say that it's similar. It's definitely congruent, and it's also similar. All right, but similar figures that are same shape, different size are never congruent because congruent means exactly the same. All right, so the angle-angle similarity theorem says if two angles in one triangle are congruent to two angles in another, then the triangles are similar. That means because, well, like in the prior question, we knew that these are similar. These triangles were similar because we had two angles that were matching up with the two angles in the other figure. So the congruence right here of 115 degrees and 115 and then 20 and 20, those corresponding angles matched up with each other. And then obviously, since all triangles equal, interior angles of a triangle equal 180 degrees, this angle E and angle C had to be equal to each other. So they were similar triangles right off the bat. And that's the angle-angle similarity theorem. Similar figures, all corresponding angles are equal to each other. That's what we were saying. And similar figures, all corresponding angles form equal ratios. And we went over that as well. Okay, so let's go on to the next page and go right here. All right, so it says use the fact about triangle sums and similar triangles to solve the problem. Triangle PQR, which is this one, PQR, and triangle STU are similar triangles. So right now they're telling us that they are similar. In triangle PQR, the measure of Q, I'm just going to say Q, P, R, right here, is 60 degrees. And PQR is a right angle. There's the right angle there. Explain how you can solve for x. So right here is your x, that measure. So please go ahead and see if you could do this. Take your time, work through it. Remember, these are similar triangles, similar figures. So that means all corresponding angles must be equal to each other. All right, we're not putting any of these into proportion because there's no sides at all. All right, there's no side lengths, I should say, given at all. There's sides, but there's no side lengths given. Only an angle, 60 degrees, and another angle, which this box, you know, means 90. Go ahead, use the information to solve for the missing angles in this one, and then solve for x. That's the main thing. This is an angle. Go ahead, try the problem, press pause now. Okay, hopefully you did have a chance to look at that. The first thing I did was right here, since these are similar figures, and this is kind of like, looks like it's rotated a little bit, and then it's actually a little bit bigger, the STU triangle. This is 60, this is 90. I know that the 90 degree angle is here, and since the corresponding angles of any similar figures are equal to each other, I know I could put 60 in here. I have to find x. So there's one or two ways that I could do this. I could do this by just adding up these two angles right here, 90 plus 60. And if I get that, that's 150. And since I have to get this angle right here, I could do 180 minus 150. And the reason why I need that is because that's part of a straight line. You could see that right here, and I'm going to highlight it. Here's your straight line. If that's a straight line, that means that this little part, it's 30 degrees plus this equals 180. So I could take 180 and minus 30 and get 150. So angle x equals 150 degrees. All right, and that's exactly what you would do. There is another way. So this is your first method that a lot of people are going to use. And it says that this is an exterior angle, that x. And these are interior angles right here, 60, 90, and 30, interior, inside. So the two non-adjacent interior angles to the exterior angle are going to be equal to each other. I'll say that again. The sum of the two non-adjacent angles, interior, the sum of the two interior non-adjacent angles is going to be equal. If you add them up, it'll be equal to the exterior angle. So 60 plus 90 equals 150. This plus this would equal this. The sum of the two non-adjacent interior angles is equal to the exterior angle. So this plus this equals that. So all you had to do was 60 plus 90 equals 150, and you could put 150 degrees here. And that's the second method. That's the more direct method, but I don't think people would use that as much as method number 1. And that's why I always do that, because a lot of people just remember, all right, this is a triangle, 180 degrees inside the triangle, so I'm just going to add up 90 and 60, not realizing that that would be the answer to this, and then subtract it from 180, get 30. And you just do 180 minus 30, and you get 150. And that is it. That's how it works with that type of problem. All right, it says explore. Triangle ABC and triangle DEF are similar. To find the measure, if the measure of angle A, and I'm going to put that in, is 53 degrees. I'm going to squeeze that in there. And what is the measure of angle D? These are similar figures, so we're just going to answer this right now. What's the measure of angle D? If this is similar to this is 90, this is 90. Corresponding angles of similar figures are congruent. They're equal to each other. This is 53 degrees. This would have to be, yes, you guessed it. So the measure of angle D equals 53 degrees. All of the corresponding angles are equal to the same thing. So what do you notice about the shape? Same shape. Different size. All right, what's the measure of angle B? Oh, wait. Measure of angle C, 90 degrees. What's the measure of angle B? Well, we have 90 and 53. How do you get the measure of angle B? Put it on your page right now. Please don't wait for me. Right? All interior angles of a triangle equal 180 degrees, and that means that you just add them together. So we're just going to put that over here, 90 plus 53. 90 plus 53 is 143. Then you take 180, because we're talking about interior angles of a triangle. Again, always take that calculator and just be sure. Even if you think you know the answer, don't do it in your head. 143. You're subtracting them. This equals 37 degrees, and that means that equals 37 degrees. Measure of angle B is 37. I'm going to put that there. So that means that, just go quickly, the corresponding angle, what angle corresponds to B in this figure? So this one, D, is 53. I'm just going to squeeze that in. And, yep, angle F would be 37. Corresponding angles of similar figures are equal to each other. Name the angle and the measure of the angle that corresponds to angle B in the triangle. So we're going to talk about, right now, putting full screen up, and measure of angle B and F. Angle F corresponds to B. All right, and the measure of angle B equals 37 degrees. The measure of angle F equals the same thing. And then it says just name the angle and the measure of the angle that corresponds to angle C. Well, angle C and angle E, we already said, correspond to each other. And the measure of angle C is definitely 90 degrees. It's given. The measure of angle E is the same thing, because it corresponds. All corresponding angles of similar figures are equal to each other. And that is the work that you need to show for that problem. All right, so here we go. Explain whether the triangles are similar. So they're not telling you that the triangles are similar. They're not telling you. So you're going to have to go through and work this out. go ahead, try, prove it. Once you say it's similar or not, just prove it. All right, justify your answer with a small sentence, and that is about it. You can try the problems, press pause, and we'll review now. All right, so the triangles are similar. No, they are not. So corresponding angles are not all congruent to each other. 60 and 55, not equal. So those are corresponding angles that are not equal to each other, and then 30 and 35 not equal to each other. Think about it. If you have corresponding angles that are not equal to each other, that means you do not have the same shape. It might look like the same shape, but it is not the same shape. It's definitely not the same size, but that doesn't matter. It's the same shape that it needs to be, right? Same size. It doesn't matter. Of course, similar figures are usually different sizes, but they have to be the same shape. And if you have different angle measures, the corresponding angle measures don't match up, you really don't have the same shapes. All right, even though it might look, because from the eye you can't tell that this is 35 degrees and this is 30. Just looking at it. So are these triangles similar? No. And then this is the justification that you must put on the bottom. The corresponding angles are not all congruent to each other. Hopefully you moved on to this next one. Are the triangles similar? Right now I cannot put an answer down, but I could circle. Let's just circle the corresponding angle here and the corresponding angle here, and you know that those are 90 degrees each. So if this is 90, this is 90. Okay. Now, do you see this angle here? Where does the corresponding angle, where is that located in the other triangle? Well, it's located right here. And since it's missing, we're going to move on. 40, where's that located here? Well, it's here. So we don't have the missing angle. So as long as we don't have the corresponding angles that we can compare. We need at least two corresponding angles that are equal to each other, and we cannot do that right now. So what I'm going to do is I'm going to solve for this interior angle, and let's see where that leads us. If this is 50 when I solve, that means that that's good enough. All right, and we could call these similar. So I am going to, again, I'm going to do 90 plus 40, because all interior angles of a triangle equal 180 degrees. I'm going to do 180 minus 130, and that is 50 degrees. So I know that this is 50, and the corresponding angles do match up, 50 and 50. And since I'm going to just check right now, this is 90 plus 50. That's 140. 180 minus 140 is 40. I know that this is 40 degrees. All right, and that's basically it. So we are saying that these are similar. And I'm going to put all corresponding angles, even though you don't need, obviously all corresponding angles are congruent to each other. And that's it. So moving on to the next page, it says explore the triangles given below are similar. Find the missing side of each. Go ahead, try the problems, both of them. We'll come back with the answers and review. Press pause and try the problems now. Okay, so here are the answers. I just highlighted, just make sure you understand that you are matching up the corresponding sides. 3/4. I just looked at the first triangle, and these triangles are similar, so I'm just matching up the corresponding sides for making a fraction, x over 10, and then you cross multiply. What we're going to do is just cross multiply like that, x 4x equals 30, and you get 7.5 when you solve. 10 over x, 400 over 280, matching up those corresponding sides. Again, I'm going to cross multiply. You have 400x, and then on the other side equals 2,800. You divide by 400 on both sides. This cancels. You get x equals 7, and that is it. So we would not, the fast finishers, try to do the fast finishers. They are more difficult questions, but you might as well do them. I'm going to do this one with you. Just think about, for this one, the sum of the angles of any, it should be say interior angles of any triangle are 180 degrees. Use this information in the diagram to write and solve an algebraic equation. Find all angle measures. So that means saying is this one, this angle, interior angle, plus this one equals 180 degrees. So what we're going to do is we're going to set up an equation. Hopefully you know that the equation must be equal to 180 degrees. All right, this plus this plus this equals 180 degrees. So we're going to start over here, 5x plus 10 plus 4x plus 2x plus 5. And we're going to move this over. All right. So that means you're setting it up where all of them, when you add every single interior angle up, it equals 180 degrees, and that is true. So we have 5x. We have 4x. We're going to combine like terms because this x is on the same side of that equal sign. That's 9, 10, 11. So we're talking about 11x. Then we're going to add 10 and 5, and it's 15. Obviously, we are going to subtract using inverse operations. This cancels. 11x equals 165. Divide by 11, and we're going to check that in the calculator. Let's see what my x is going to be. 165 divided by 11. 15. So we have x now, but we don't have all angle measures. So we're going to substitute in here. We're going to put 5, and instead of x, we're going to substitute that 11 in. 5 times 11 plus 10. So that is 55 plus 10, which is 65 degrees. So this right here is 65 degrees. Then we're going to do 4 times 15. And that equals 60 degrees. So this is 60. And then we're going to do 2 times 15 plus 5. And that equals 35 degrees. So, do you see something that I did incorrectly? See, now I'm looking at this, right? And I'm hoping that you understand that if you do something like I just did, that you could stop yourself and say, all right, this is wrong. Something's wrong, right? So if I add 60 plus 65 plus 35, let me just add that up right now. It should be equal to 180. And in your head, it's not like you have to take a calculator out to do this. 65 plus 60 plus 35, it doesn't seem that's 180. So something's wrong. Can you see where it is? All right, well, x is 15, right? Look what I put in for the first one, because I was rushing. So this is supposed to be 15. And that means that this is not 65. mistake. So let's see, 5 times 15, parentheses, plus 10, 85. Be careful. Now 85 plus 60 plus 35, that equals 180, and I have the right answers. So just stop yourself, look at it, just look at it. Don't turn the page. Look at it and say, wait, this plus this plus this doesn't add up to 180. Something's wrong. And then you could quickly fix that problem. All right, let's go on to the mid-level assessment. Just take a look at this. It says, given that triangle ABC is similar to triangle XYZ, which is not true. Remember, you're looking for something that is not true. Not true of these triangles. Go ahead, see if you can do the problem. Press pause now. Whenever I do these problems, I write true on the top. The easiest thing right here is to cancel out A, because that is true. These are similar. So that means that corresponding angles are equal. So that means angles C and Z are corresponding. They're equal to each other. BC, let's go ahead and use that highlighter. BC over YZ. Okay, that's good. BA over XC. That's false. Not true. False. B. Just to move on to another one, this is BC over YZ. That's good. And then BA over YX. That's true. That's good. Matched up corresponding sides. I'm trying to write in highlighter. That's out. I already have my answer. It's B. Just showing you. BC, which is this one, over YZ. Again, AC over XZ. That's true. They're looking for something that is not true. We have B. B is your answer, and that is it. So here's the fast finisher, and the fast finisher is kind of a difficult problem. So let's read. The perimeter of a triangle is 59 centimeters, and the first side is 7 centimeters shorter than the second side. The third side is 4 centimeters shorter than double the length of the first side. If you read all of this, it's very confusing, but the first thing I always thought of is perimeter equals 59 degrees. 59 centimeters, and I said, wow, it's not 59 degrees. Still in angles. I said, wow, all right, so you add up all the sides, and that has to be equal to 59. So I'm going to add up all the sides here. Then I put down a key. The first side is 7 centimeters shorter than the second side. So the first side is 7, so the second side is X. All right, so the second side is X. The first side is 7 shorter than X. So how do we write that? 7 shorter than X, the first side. 7 shorter than X, X minus 7. The third side is 4 minus 4. 4 centimeters shorter than double the length of the first side. So how do we put double the length of the first side? The first side is X minus 7. Double that is 2 times X minus 7. Double. And then 4 shorter than that is minus 4. All right, so the key will help you kind of like make sense of all of this. And so we want you to put the key down, because without the key, it's, it's really difficult. So I'm going to add up all of these sides. So I'm going to put X minus 7 plus X plus 2 times X minus 7 minus 4. And that all equals to 59. We are going to combine like terms, but before we combine like terms, please go ahead and do distributive property. and go ahead of me right here. So we're going to bring everything down, because we're not going to just try to combine any like terms. This is 2 times x is 2x, and then 2 times negative 7 is negative 14 minus 4 equals 59. All right, so far so good. We're going to combine like terms now. We are going to combine the x, the positive x, and the positive 2x. Okay, so that's 4x. Then we're going to take the negative 7, the negative 14, and the negative 4. So I'm going to take my calculator out for that. Negative 7 minus 14 minus 4. Negative 25. Equals 59. Then obviously you're going to add 25 to both sides. This cancels. Then you have 4x equals, and 59 plus 25, just to make sure, is 84. Divide by 4 on both sides. X equals 21. Take it one step at a time. So now we're going to take this 21 and we're going to find the length of each side. So it is 21 minus 7. That is 14. First side is 14. The second side is 21. And the third side is 2 times 21 minus 7 minus 4. So 2 times 14 minus 4. And that is 28 minus 4. And that is 24. Third side is 24. And that's how you do that fast finisher. It's a tough question, but you can get through it. The key is completely necessary. Key is completely necessary. All right, here is the mid-lesson summary. Please go ahead, press pause, write down what you know about corresponding angles and similar figures, and draw an example of similar figures with corresponding angles. What do you know about corresponding side lengths? Draw an example of proportional side lengths in similar figures. Go ahead, press pause, we'll come back and review. Okay, so what do we know about corresponding angles and similar figures? I put down, and you should put down this exact thing if you didn't already. Hopefully you did. Corresponding side lengths are congruent, equal in similar figures. All right, and I drew an example of 2 triangles that we've seen a number of times before, where the corresponding angles are equal to each other. This is equal to 30, and this is equal to 30, this is equal to 90, this is equal to 90. All corresponding angles are equal to each other. So, number 2, what do we know about corresponding side lengths in similar figures? Corresponding side lengths form equal proportions and ratios in similar figures. Draw an example of proportional side lengths, same figures. There's 2 triangles that are similar, same shape, but not necessarily that same size. One side is 2, the corresponding side length is 4. The bottom side is 6, the corresponding side length is 12. And they will double, and you could see that they will form equal ratios. So it would be like 2 over 6 equals 4 over 12. Times 2. Times 2. If you cross multiply, you get 24 equals 24, and that's how you know the cross products are equal. That's how you know that they are proportional. All right, and that is it. Hopefully you did that. All right, go ahead and see if you can answer the questions below. Be sure to justify your answers. The figures below are similar to each other, so we are looking for the measures of angle 2 and 3. Very easy right now. Remember, similar figures have corresponding angles that are equal to each other. congruent, and then find the measure of x, side x, by forming a proportion, creating a proportion, and solving that proportion for side x. Press pause and try the problem now. Okay, so hopefully you did get this. This is pretty easy. 76 right here, corresponding angle in the smaller figure is 76 degrees. They are equal, so measure of angle 2 is 76. Here's the measure of 107 degrees in the larger figure. In the smaller figure, that matches up. The corresponding angle is the same. It's equal, so measure of angle 3 is 107 degrees. Then I use the highlighters to identify the corresponding sides, both yellow corresponding and both green corresponding. So I put x over 20 using the first figure, the sides of that first figure first, equals 33 over 15. All right, when you go ahead and create your proportion, you cross multiply, that's basically it. X equals 44. Okay, and it all is that the figures are similar to each other, so that's why we were able to do all that. Remember, similar figures have corresponding sides that form equal ratios, and the corresponding angles are equal to each other. They're congruent. All right, and we're going to go on to the next question. Please go ahead. These figures are similar to each other as well. Please answer all of those questions about the similar figures. Do remember, all the angle measures, not very difficult. There might be an angle measure that you have to think about, like adding the two other angles and subtracting from 180. Go ahead, give it a try, press pause, and we'll review the answers now. So I did the two corresponding angles here. Look, C is given, it's 25 degrees, so I put that directly in. This is 25 degrees as well. I wish they would put that up there, but they probably couldn't fit the print. That's 25 degrees. The corresponding angle is Z, it's 25. B is 85. Angle Y is 85 degrees because they are corresponding angles and these are similar figures. We have to find A though, and we have to find this question mark, which is angle X. So what do? We have two interior angles of a triangle. Interior angles of a triangle, if you add all three, equals 180 degrees, and we are not there. We only have two. So hopefully you are able to just do 85 plus 25. And get 110. And so here we go again. So remember, interior angles of a triangle equals 180 degrees. You subtract whatever sum of the other two angles, interior angles are, and get 70. So angle A is 70 degrees. That means angle X, which is the corresponding angle in that similar figure, is the same thing, so 70 and 70. Okay, so here we go. Find the measure of YX. So that means we need this. So I'm going to take my highlighter out, and I am going to highlight that right there. And I'm going to highlight this right here because that's the corresponding side. The only other side that they give me is this side and this side. So I can make a proportion out of that. So let's see. We have 6 over 4. 6 over 4. 12 over, and I'm going to put X. So you are supposed to cross multiply, and hopefully you did already, and you're just watching how to make sure that you did this correct, and you have that. Let's see. We have 6 times X, which is 6X. 12 times 4, which is 48. Divide by 6, divide by 6. And just to make sure, even though I know, that the answer is 8, we're going to use the calculator. So this side is 8. 6 doubles to 12, and 4 doubles to 8. And that's it. Not too shabby. All right, here we go. Line M is shown on the coordinate plane below. Which proportion is written correctly? So correctly using the corresponding sides. So go ahead, see if you can highlight the corresponding sides and make sure that you understand that they have to be matched up into a proportion to be a good proportion. Try the problem. Press pause now. So if you picked A, you are correct. Let's just go over just a quick little synopsis of this. This is AB. And he puts it over BC. So I'm going to change the color. So he has to do the same thing. So the same thing has to be done. ED. By the way, this side here corresponds with this one. What happened is that it flipped and it expanded. All right, it enlarged. Right, so this flip, the smaller triangle flips over, and now this AB is located here as ED. Hopefully you do see that. And then DC is down here where BC would be. All right, so that matches up as a proportion. Like so, if you did BC over AB, which is this, ED all of a sudden doesn't match with BC. See how BC is on the top and then ED is on the top? That doesn't match. So that's why B is out. And the same reasons for C and D, they don't match up. All right, and that answer is A, the correct proportion, using corresponding sides. So this is a fast finisher. Please you do the fast finisher. This is not that bad of a question. It says create an equation to solve for x, find a measure of each angle. Go ahead, see if you can do it, press pause, and try the problem now. Okay, so this is the fast finisher. I basically took all the expressions inside of the triangle and set them up into an equation, adding them up, equaling 180, because all interior angles of a triangle equal 180 degrees. You have 8x minus 1 plus 3x minus 9 plus 3x plus 4 equals 180 degrees. I combine like terms where I have 8x plus 3x is 14x. Then I combine a -1, a positive 9, and a positive 4, and I get positive 12. And I subtract the 12 on both sides. I get 14x equals 168. You divide by 14, you get x equals 12. Don't forget, you must substitute. All right, so we have 8 times 12 for the x minus 1. 8 times 12 minus 1 is 95, so I put 95 degrees here. 3 times 12 plus 9 equals 45. I put 45 here. 3 times 12 plus 4 equals 40. That is it. So the way you could check this, you have 95 plus 45 plus 40, and then you put that in a calculator. It does equal 180 degrees, and you know that you're correct. Right? So all interior angles equal 180 degrees, and that's basically it. All right, investigation, please answer the questions below to the best of your ability, and we'll see if we get through this. Go ahead and see if you can do A and B and justify your answer. Press pause and try the problems now. Okay, so I did change this problem a little bit because it was kind of redundant with the A and the B, so you could change it on your page as well. Rectangle A was rotated and translated to rectangle B. I don't really even like this figure the way it looks on the page, because it does look like after when it was rotated, and rotated is like just a turn. so it turned. It was rotated and translated. Translated means that it moved down or moved across. All right, it shifted. So rectangle A was rotated and translated to rectangle B. Are the rectangles congruent, similar, or both to each other after the rotation? So I did change this a little bit because I found it a little bit redundant. So let's take a look. It looks like they're different rectangles, right? And they don't look the same, but it's just a picture that's a little bit messed up on this. Just to make sure, I'm counting the boxes. See how wide? This is 3 wide, and so is this. When I say, oops, it's supposed to be 3 wide. It is 3 wide. And then let's see, 1, 2, 3, 4, 5, 6, corresponding side, whatever side, doesn't matter. 1, 2, 3, 4, 5, 6. So they are the same figure. Did not change in shape or size. Did not change after rotation and translation. So the rotation is a turn, and translation is a shift or a movement to the rectangles, right? So I'm going to put down did not change shape or size. And the way you kind of look at it, say, all right, since it did not change the shape or size, the figures are congruent. But since the figures are congruent, that means every, and this is a star here, every set, every pair of congruent figures are also similar. All right, please write that down. Make sure you know that every pair of congruent figures are also similar. But similar figures cannot be congruent because similar figures are already different sizes. All right, so congruent figures, once you say it's congruent, it means it's same shape, same size. Those figures also fall into the similar category because they have corresponding angles that are equal, and they also have corresponding sides that form equal ratios, because it would be exactly the same thing. Like this ratio, even though they're specifically congruent figures, would be 3/6 equals 3/6. And yes, they form equal ratios. It's exactly the same thing. So every congruent figure, all pairs of congruent figures are also similar, but not the other way around. And I just wanted to, to note that in this lesson. All right, there is the fast finisher. Give it a try and see if you can do it. It's exactly the same with different expressions as this one right here. So if you did this one, you could definitely do this one. Go ahead, give it a try. We're going to press pause and we'll come back with all of the answers right there, right now. Press pause, try the problem now. Okay, so here are the fast finisher answers, and it did come to a decimal. I rounded it off to the nearest tenth, which is 9.9. 7x plus 8 plus 7x minus 1 plus 5x plus 2 equals 180 degrees. Combine all like terms with the x's, and you get 19x, and then 8 minus 1 plus 2. That is a minus 9. No, it isn't. It's a plus 9. Hold on. Yep. Normally, if it comes to a decimal, I'm not saying it's not going to come to a decimal at this point, but if it comes to decimal, maybe in this type of problem, you made a mistake, and I did. I put a minus 9 instead of a positive 9. I corrected that. Then I subtracted 9 on both sides, as you see, and it comes to a whole number right here, x equals 9. And then I substituted n, and you see your answers. I got 71 degrees, 62, and 47. All right, and that is the fast finisher. Okay, so moving on to this, finding all unknown sides. Go ahead and see if you can do this using all of what we know about proportions. Please go ahead and show your work. Remember, all 3 triangles are similar. All right, and don't worry about that fast finisher. Go ahead, create proportions using the sides, show your work, and then we'll come back and review. Press pause now. Okay, so let me just explain what I did. There's a lot of different ways that we could do this, and I just picked one way. I put 12 over 3 here equals 36 over x, because I'm looking for this. When I solved, I got 9, I put 9 here. Then I moved over and I want to solve for y. I used 12 over 17 equals 36 over y. All right, matching up the corresponding sides, I cross multiply, I got 51 here. Then I moved on to the largest triangle that is here. I went back, since all of these are similar, I'm allowed to go back to 12 over 17 equals z over 204, just matching up the corresponding sides of the smaller and the largest. And then when I cross multiplied, I got z equals 144. I put that here. Once I had 144, I went back to the original triangle, 12 over 3. 12 over 3 equals 144 over w. And I cross multiplied and solved. I got 36 as my w. And that is it. It says the fast finisher did mention about some other way of doing it. You could see that there are multiples of each other here to get to one to the other. And if you could figure out those multiples, there's like 36. If you could figure out those multiples, then you'll be able to just go ahead and see what that is. So it's 36. It basically times 3 would make you go to this one. Like 12 times 3 would be 36. 3 times 3 would be 9, and then 9 times 4 would make you go to 36. 36 times 4 would be 144, and 51 times 4 would be 204. So, like, I mean, you could do it by like multiplying multiples, and you could do it the way that I have on the screen, and that is it. All right, so here we go. State if, it should be, each triangle pair is similar. Use the similar symbol to state if the triangles are similar to each other. So take a look at the triangles here, right here, and state that if they are similar to each other. So this triangle here is HCD, and we want to see if it's similar to XCK, the larger triangle. See if you could do that. Use the sides. There's no angles here to worry about, so we're just matching corresponding sides, forming a proportion, and then cross multiplying to see if the cross products are equal. Go ahead, see if you can do that first problem. We'll come back and go over it. Press pause now. Well, I'm not going to do anything different. I'm just going to take the smaller triangle right now. I'm going to take 19 and put it over 3. All right. And then I'm going to take the larger one, matching up the corresponding sides, 38 over 6. All right, matching up those corresponding sides. Now I am going to cross multiply. Right? So I'm going to do 19 times 6 first. I'm going to see if the cross products are equal. And if they are, these are similar figures. If they're not similar. So I'm going to get the calculator up. And I'm going to do 19 times 6. 19 times 6 is 144. 114. Sorry. That could be a problem. If 3 times 38 is the same thing, it is. These are similar. Cross products are equal. Similar figures. Do the same thing for this one. Give it a try. See if they're similar. And put if they're similar or not. Go ahead. Press pause now. And there you have it. I matched up 19 over 3. The smaller triangle, and I took the larger triangle, 57 over 12. I cross multiplied. I found that 228 does not equal 171, and that's it. And I wrote my math sentence. Triangle ZSX and triangle KSR are not similar. The cross products are not equal. Justifying my answer and everything like that. That's how you do those two problems. Here is the exit slip, and there is a fast finisher here. Go ahead, see if you could do the exit slip first, then move on to the fast finisher. We'll go over both when we come back. Press pause, try that exit slip right now, and we'll discuss it. Okay, so I drew two triangles, and triangle M and N. So they said triangle M, and they're similar to each other. That's the first sentence. So they have two angles. Triangle M has two angles, 32 and 93. I put 32 degrees in here, and I put 93 degrees in here. So they're similar. That means the corresponding angles are equal. So that means they're asking for which two angle measures could be included in triangle N. So I'm going to try to find this angle measure. So since I know that interior angles of a triangle equal 180 degrees, I am going to do 93 plus 32. Right? And I have the calculator. 93 plus 32 is 125. 180 minus 125. Let's see. Is 55 degrees. So I know that this 55 has to be within the answer because they're asking for which other two angles. So there's the 55. 55 and 93. Good. See what two angle measures could be included in triangle N. There it is, and that is my answer for the exit slip. The fast finisher says triangle ABC is similar to XYZ because two pairs of corresponding angles are congruent. So that means the two pairs of corresponding angles are congruent, this one and this one. Which one does not help prove that the triangles are similar? Which of the following does not help? Okay, so let's see. I have to get B. The sum of measures triangle ABC equals 180 degrees, so angle B, so the measure of angle B is 25, does not help prove that the triangles are similar. So that would help prove that the triangles are similar. So if this was 25, that would help prove it. So this would help prove, they're asking which one does not help prove the triangles are similar. So the sum of measures of ABC equals 180 degrees, so angle B is 25. That would help prove because angle Y is 25. So this one is good, that's out. Angle B is 25 and angle Y is 25. That would help prove, so that's out. Measure of angle C is 65. Measure of angle Y is 25. Ooh, these are not corresponding angles, so that wouldn't help connect. So if they said measure of angle C is 65, measure of angle Z is 65, that would help. That does not help prove. Measure of angle A, just let's check. Measure of angle A is 90 and measure of angle X is 90. That's good. We are out with that one. This is good. This is good. C is your answer for the fast finisher. That is the only one that doesn't prove that, doesn't help prove that the triangles are similar. Remember all similar figures. All right. And this is what you could put for your summary. All similar figures create the side lengths, create equal ratios, equal proportions. All similar figures, corresponding angles are equal to each other, right? So remember, you could put stuff like in the summary, congruent figures are exactly the same. Same shape, same size. Similar figures, same shape, different size. Remember, put a star on this. All similar figures. All similar figures are just similar. They're different size. But congruent figures are also similar. And congruent figures, it goes back to that star that we put in the mid-lesson. All similar figures are just similar, but congruent figures could be also similar. Same shape, but not necessarily the same size. All right, and that's what you could put for your summary. Thank you for watching. That ends the lesson.